Hi guys, today we will talk about packing problems. So according to joycemat.com, packing problems are a class of optimization problems in mathematics that involve attempting to pack objects together into containers. The goal is to either pack a single container as densely as possible or pack all objects using as few containers as possible. Many of these problems can be related to real-life packaging, storage, and transportation issues. Each packing problem has a dual covering problem, which asks how many of the same objects are required to completely cover every region of the container where objects are allowed to overlap. So in simple terms, we can say that packing problems covers the topics where a figure is covered by another figure. So we can say that if there is a square, we can add a triangle and we will solve how much space does the triangle gets in the square. We'll just get the square units that are used by the triangle inside the square. So we can say that that is a packing problem. Another example is there is a circle. There are four circles that are aligned and the center of the circles are connected to form a square. So we will get the area that is used by the square inside the circle. So that is packing problem. So now, let's proceed to the real life examples for the packing problem. So for the examples of the packing problem, we know that packing problem is getting the percentage of how much does a thing occupies another thing, or the smaller thing to the larger thing. So for the first example, imagine that a balikbayan have a box that inside this box there is another box. So for the larger box, we have an edge of 5 centimeters, and for the smaller box there is a 1 centimeter edge. To get the percentage of how much does the smaller box occupy the larger box, we just get their volumes and then divide times 100. So 1 cube divided by 5 cube times 100 is equal to 0.8%. That is how much the smaller cube occupies the larger cube or the box. For the second example, this is a square land with a post with a square base. Because this is only just the area, we just compute how much area does the post, its base, occupy the land. So the land measures 10 meters, and for the post, its base, its square base is 3 meters. So we just get the areas of the squares times 100. So 3 squared times 10 squared times 100 is 9%. So the square base of the post is 9% of the square land. So for the third example that this is a high-rise building. It is in a form of a parallelogram. So for its height, it has 20 kilometer height. For the length, it's 6 kilometers, and for the width, it's 10 kilometers. And then we will compute how much space does a square room occupies the whole building. So we just get the volume of the square room. Its edge is 5 meters. So we will just convert it to kilometers to get the same unit. So 5 meters is 0.005 kilometers. Cube, we just cube it because it is the volume. And for this is now rectangular parallelepiped in volume, which is 20 times 6 times 10. So we just divide 0.005 cube over 20 times 6 times 10 times 100. We'll get the answer of 0.0000375%. Or to make it simpler and easier to understand, we will transform it into scientific notation, which is 3.75 times 10 raised to negative 5%. So that is how much the square room occupies the larger building. So that's all for our packing problem tutorial. Thank you for watching. This is just a simple tutorial. To learn more, you'll need just to search for the internet and look for other examples to challenge your brain in solving these problems. So that's all. Thank you for watching, and watch out for other videos to learn more. That's all. Thank you.